right, so these are the day 10 notes. These are the 12.1 basic equations. So please pause the video and write down these equations that you should already know. And here are more equations. Pause the video if you need to write these down. All right, so let's get into the practice problems. So we're going to find the equation of the line in slope-intercept form, which is y equals mx plus b, given that the point goes through -2 and +4. It's parallel to 2x minus 3y equals 1. So that means we should solve for y so that we can find the slope. So when we do that, we get an equation of y equals 2/3 x minus 1/3. And this tells me that the slope is 2/3. So if two lines are parallel, we know that they have the same slope. So this new equation should have a slope of 2/3 also. So if you want to use a point slope equation, you have y minus y1 equals m times x minus x1. And we get y minus 4 equals 2/3 times x plus 2. And then it does say it needs to be in slope-intercept form, so you're going to have to solve for y. So you have y minus 4 equals 2/3 x plus 4/3. When you add 4 to both sides, you get 2/3 x plus 4/3 plus 12/3, which is 16/3. So your final answer would be y equals 2/3 x plus 16/3. All right, so moving on to number 2, this time we're going to find the equation of a line that goes through the same point, -2, 4, but this time it's perpendicular to 2x minus 3y equals 1. So we'll just use the same slope that we found before, which was 2/3. This time, when we look at our equation, we need to make sure that we have opposite reciprocal slopes. So this time our slope needs to be -3/2. So we're going to use our point slope equation, y minus y1 equals m times x minus x1. This time we're going to substitute in -3/2 for our slope and the same point as earlier. So it'll be x plus 2 and y minus 4. And then we just need to solve for y. When we distribute the -3/2, we get -3/2x minus 3. And then we just have to add 4 to both sides. So we get -3/2x plus 1. Moving on to number 3, this time we're going to find the equation of a line, still in slope-intercept form. This time it's parallel to our original equation 2x minus 3y equals 1, which is the same equation we used in number 1 and number 2. But it has the same y-intercept as 3x plus y equals 5. So because it's parallel, we know that the slope is going to be 2/3. A y-intercept, remember, is 0, comma y. So we should find our y-intercept. So if I put it into slope-intercept form, I have y equals -3x plus 5. This means that my y-intercept is 0, comma 5. Because we know our y-intercept, we don't need to use point slope form. We can go right to slope-intercept form. So our equation is y equals 2/3 x plus 5. And then we're finished. All right, moving on to circle equations, we are going to practice completing the square, which we've done throughout this chapter. So x squared minus 6x plus something, it needs to be half of this middle term squared, so -3 squared is 9. Remember that whatever you add to the expression has to also be subtracted, so make sure you subtract 9 to balance out the original expression. And then we're going to factor the trinomial, so that becomes x minus 3 squared, and then minus 9. And that's equivalent to the original expression, x squared minus 6x. For the next one, we have x squared plus 12x plus something plus 4 equals 0. If we come up with half of the 12, that's 6. 6 squared is 36. And because it's an equation, we can add 36 to the other side to balance out our equation. So now we're going to factor this trinomial. So we get x plus 6 squared plus 4 is equal to 36. And this equation is equivalent to the original x squared plus 12x plus 4 equals 0. All right, so we're going to use the concept of completing the square to find the equation of the circle. And because we have an equation, we're going to try to balance out both sides of the equation. So I'm going to first work on completing the square for the x terms. And then I'm going to complete the square for the y terms. But whatever I do to the left side, we're going to balance it out on the right side. All right, so I'm going to take half of -4, which is -2. -2 squared is 4, and whatever I add to one side, I have to add to the other. Then I'm going to take half of 2, which is 1, and 1 squared is 1. So I'm going to add that to the other side as well. Then I'm going to factor the trinomial. So that gives me x minus 2 squared. Then I'm going to factor the other trinomial. This is going to be y plus 1 squared. And then I'm going to simplify the right side. So that gives me 20. So there's my equation of my circle. And then the center of the circle is at 2, -1. Make sure you do the opposite of x minus 2 and the opposite of y plus 1. So we look at the 20 to find our radius. R squared is actually 20. So that means that r is the square root of 20. And a better way to write that would be 2 root 5. Moving on to the next equation, we have x squared plus 8x plus something plus y squared minus 6y plus something equals 50, and then whatever I add to the left side, I have to add to the right side as well. So now I want to take half of 8, which is 4, and 4 squared is 16, so I'm going to balance that out on the right side. And then half of -6 is -3 squared is 9. So I'm going to add 9 to the right side. Then I'm going to factor the trinomial, so I get x plus 4 squared, and I get y minus 3 squared. And then 50 plus 16 plus 9 is 50 plus 25, which is 75. So that's my equation. My center is -4, 3. And then my radius is the square root of 75, which you could simplify to be 5 root 3. For this next problem, we need to find the area of the circle. So as a reminder, the area of a circle is equal to pi r squared. So the thing that we would need to identify is the radius. So we don't need to complete the square. It's already in the standard form for the circle equation. And that means our radius is 8. So all we need to do is find the area, which is pi times r squared. So that means that our area of our circle is 64 pi. Moving on to number 2, it says find the x and y intercepts of the circle. So if I want to find my x-intercept, remember that that is some point that's x comma 0, so that my y is equal to 0. So I would suggest taking your equation and making anywhere you see a y equivalent to 0. And then now I just have one variable x to solve for. So I have x minus 10 squared plus 5 squared, which is 25, equals 64. Then if I subtract 25 from both sides, I get 39. So remember, you're trying to solve for x, so you're going to take the square root of both sides. When I take the square root of both sides of an equation, I get plus or minus whatever I get. So it's plus or minus square root of 39. 39 is 13 times 3, so there's nothing we can do to simplify that. And then we just need to add 10 to both sides. So that means that I have two x-intercepts. So one of them is at 10 plus the square root of 39 comma 0, and the other is at 10 minus the square root of 39 comma 0. And then we're going to do the same thing to find our y-intercepts. So as a reminder, y-intercepts are always at 0 comma y, so that means make your x equal to 0, and then solve for y. All right, so negative 10 squared is 100. And then if I subtract 100 from both sides, I get negative 36. So when I try to take the square root of both sides, I could tell that I'm going to get an imaginary, which means that I do not have any y-intercepts. All right, as an illustration as to why you have x-intercepts but no y-intercepts, if we were to graph this circle, we would graph it at 10, negative 5 would be our center. And then our radius being 8, I would go up, down, left, and right 8 units. So from 10, I would be at 18 here. I would be at 2 over here. I would go up 8, that would be at 3, and I would go down 8, that would be at negative 13. So as you can see, it crosses the x-axis twice, but it never crosses the y-axis. That's all for these notes, so if you have any questions, please ask your teacher.